Okay, now we're on the polynomial inequality. And this is new, something you have not done in Math 100 at Essex County College. All right, so I want to, again, claim to you that the problems that we give you, there's solutions here in the blue area, and there's also videos over here if you want to watch those. Now, this is a lecture format. A lecture format, what we do is present the material. You can always come back later in the week to rewatch this or simply watch the spot videos if things go too quickly for you. The goal, though, is that even if it goes too quickly for you, please listen, try to follow. You want to be able to do this on your own. Listening, following is going to be an important skill set. All right, so I'm going to switch to the whiteboard and I'm going to start working problems. All right, and I'll talk about that so I go to work problems, what we want you to be able to do. All right, so want to point out we're doing the problems here. Let me go backwards. Sorry about that. And go back to the page I want to get to. Just give me a second here. And so we're going to do example number 1 now. So example number 1 says, solve and express a solution set using instrumentation. And certainly we've discussed how we want you to do it. So the first thing to do is make sure that you understand this is a quadratic inequality. It's not linear, it's quadratic. And there's many ways to do it. I'm not saying there's only one way to do something. But the problem now is that the steps that we've outlined for you, the first step is to make sure you have it compared with 0. And I clearly see that. So I'm looking at it. What do I see? I see x squared minus x minus 6, which is a trinomial of degree 2. And I have it being compared with 0. So this is a great first step. My next step is to completely factor that polynomial, if possible. Now, again, we're hoping it's going to work out pretty nicely for you. And you're going to get a lot faster over time at this. So you get x and x. You've done factoring in Math 100 and 092 as well. And I'm looking at the 6, and I'm going to say 3 and 2. Whatever I say, I'm going to check it. Minus 3 plus 2. Let me just check that. What do you get? X times x, x squared. Then you get minus 3 plus 2, which is minus x, and you get minus 6. All right, so here's the deal. Compared to 0, completely factored. We're done with that. The next thing we're going to do is put a number line down, and on that number line is list the zeros of those factors. Well, one of the zeros would be at minus 2. The other 0 would be at 3. Now, they should be in proper order, by the way. What you're going to do now is test out the intervals, and there's 3 intervals to test. This interval, and this interval. You need to find a value in that interval that you're willing to test only for sine. So let me just put the number after 3. I'm going to say a good test point there would be probably after 3, I would say x equals 4. If you're to plug it in, I want to point out where you're plugging it in here, and you're just analyzing sine. So what do you get for the first factor? Well, 4 plus 2 is 6, so the factor is positive. And 4 minus 3 is 1, so it factors positive. Now, what's a positive times a positive? It's a positive, right? Now, someone says, what does this mean? It means the number there is positive. All right, we'll get to the question later. Let me take a number between minus 2 and 3, and I would say a good test point here would be x equals 0. You're going to plug it in to the factors, and what do you get? 0 plus 2 is positive, and 0 minus 3 is negative. Now, a positive times a negative is a negative value. So let's go to the one below minus 2. What's a good test point below minus 2? I would say x equals minus 3. And what do you get there? Well, if you plug it in, what do you get? You'd get, minus 3 plus 2 is minus 1, which is a negative number. And minus 3 is minus 6, which is also a negative number. What's a negative times a negative? It's a positive. So what I'm going to claim over here is the interval below minus 2 is positive. I'll put this down for you. The interval between minus 2 and 3 is negative. The interval above 3 is positive. I'm doing one. Now comes the story. There's a question to it. What does it say? And I want to point it out to you. It says, when is it less than 0? When is it equal to 0? We hope you realize the reason we choose 0 is numbers that are negative are less than 0, and numbers that are positive are greater than 0. So what numbers are we looking for? Numbers are less than 0. What numbers are less than 0? Negative numbers. So this gets shaded in. All those negatives. What's the other question? When is it equal to 0? Well, if you plug in -2, you would certainly get 0. That gets shaded. And if you plug in 3, that also produces 0. That would get shaded. So what's the answer over here? -2 up to 3. The gold standard of solving an inequality is getting the interval. That's going to involve the technique we described to you, including graphing. The answers are listed here. Let's go to the next question, which is number 2. Now, again, if this goes too quickly for you, I want to point out to you, later in the week, this video will be published and you can rewatch it if you want. Or if you prefer, you can watch the spot video just by going back to the notes. And if you're on the internet, those notes will be linked to videos. All right. So let's take a look at number 2. And I'm going to point out what I want to do with number 2 is it's got to be compared with 0. And clearly that's already done for me, but I have to factor it now. And someone says it's really difficult to factor. You need to practice. I'm going to say it's going to be pretty easy to do because the numbers are nice and small. In other words, trial and error is going to work out nicely. So 2x times x will give me 2x squared. And then I would probably say, let's take a look at that. I'm going to say 4 and 3. Put that down for you, 4 and 3. And let me see, plus 4 minus 3. Here's the deal. No matter what I say, I want to see if it's right. I went to 2x times x, 2x squared. That worked. 2x times 4 is 8x, minus 3x is 5x. That worked. And I do get minus 12. Now, what goes on a number line now? The zeros of those factors. Well, look at it. X plus 4 becomes 0 when x is minus 4. When does 2x minus 3 become 0? If you're struggling with this, write it down. I hope you're not struggling with it, but if you are, write it down. 3 over 2. It's over here somewhere. Now, I hope you realize that 3 over 2 is 1.5. All right, what am I going to do now? Well, again, I want to say over time you get faster, but right now we're not looking for speed. We're looking for you to take a test point. So I'm going to say over here, what's a good number after 3 halves? Well, remember, 3 halves is 1.5. So I can say a good test point here would be x equals 2. Let's do this one. What's a good test point between minus 4 and 3 halves? I would say a good test point here would be x equals 0. Let's go over here. What's a good test point over here? Below minus 4, I would say x equals minus 5 would be a good test point. All we're doing is analyzing sine of it. It's called sine analysis. Let's start with the 2 first. If I put 2 into the first factor, I want to point out what we're looking at. We're looking at this over here. What would you get? A positive number. Now, why is that? 2 times 2 is 4. 4 minus 3 is 1. Positive number. Second factor, positive. A positive number times a positive number is a positive number. So this interval here is always going to be positive now. All right? Let's try 0. If you plug in 0 to the first factor, which is 2x minus 3, you would get a negative number. Again, 2 times 0 is 0. 0 minus 3 is negative 3. It's a negative number. If you plug in 0 to the second factor, which is x plus 4, you get 4, which is a positive number. What's a negative times a positive? A negative number. So what's this interval over here? It's always going to be negative, that interval. All right, let's try minus 5. If you plug in minus 5 to the first factor, what would you get? Well, you get minus 10 minus 3, which is minus 13, a negative number. If you plug in minus 5 to the second factor, you would get minus 1 because minus 5 plus 4 is minus 1, which is a negative number. What's a negative times a negative? A positive number. So this interval here is always going to be positive. Now, here's the deal. You got to know what the question is. What's the question? I want to point it out to you. When is this thing here greater than 0? When is this greater than 0? When it's positive. So it's positive here and it's positive here. They're not asking about equality. So all I'm going to do is shade this in now. I'm going to shade this in now. That's my graph. Again, our gold standard is to write the interval down. Where's it going? Well, it's starting off at minus infinity. Let me go back to black ink. Starting off at minus infinity. It's going up to minus 4. That's on the right side, but it's not touching it. We have conventions. Union. It starts up at 3 halves. That's on the left side. We're not touching it. The convention for not touching is parentheses, and it's going off to infinity. Look at the key. Make sure you can agree with what we're saying is true. All right. Now, again, I'm going to say if you're catching on to this, which I hope you are, you should say to yourself, every problem is going to look the same to me. What changes is maybe the level of difficulty in factoring, manipulation, whatever. Well, let's take a look at it. So what do I got to do? First, number 3. So in number 3, I got to be honest with you, it doesn't look that bad to me. However, it is a cubic polynomial. Here's the deal. We're not going to give you something you can't do. So if you remember back in Math 100, to factor this thing over here, they probably would have said factor it by grouping. Now, what does that mean? You're going to take the first 2 terms and the second 2 terms and factor them by grouping. Let me put that down. The first 2 terms factor by pulling out x. And what do you get there? X squared. 2x minus 3. That's a common factor between those 2 terms. In Math 100, I hope most of your teachers, at least you had, told you to use this sign. Not that it always works, but for the most part, it always works. So I'm going to do, what's common between 32 and 48? Well, I'm going to say 16. Yes, you would have to know numbers to know that. What do you get there? 2x minus 3. All right. There were 4 terms. Now there's 2 terms. Do those 2 terms have a common factor? They do. What is that? 2x minus 3. What's left over? X squared minus 16. Continue to factor. Continue to factor. What do I see? 2x minus 3. X squared minus 16 is x plus 4, x minus 4. What do I do now? Number line. What goes on the number line? The zeros of those factors. How many factors are there? There's 3 factors. There's going to be 3 distinct zeros in this case. What are they going to be? Well, I'll write them down for you. Plus or minus 4. That was easy. 2x minus 3. Again, if you're struggling with this, all I can say is write it down. When does 2x minus 3 equal 0? 2x equals 3. Boy, this is familiar. 3 halves. Where's 3 halves? It's 1.5. I'm just going to put them right over here. All right. I'm going to say this over and over again. By trying, you're going to get faster. If you don't try, you'll actually get slower. But I want to start trying. What am I going to try? I'm going to try using some test points here. What's a good test point after 4? I'd say 5. If you plug 5 in, you might be able to do it in your head. What are you going to get? First factor become a positive number. Second factor become a positive number. And the third factor be a positive number. I hope you realize overall you'd get nothing but positive numbers. So I'm going to put that down. The result's going to be positive forever. All right. Now, I realize for some, so looking at, 3 halves and 4, I can't think of a number. Of course you can. X is, 3 halves again is 1.5. All right. So what's a good test point? I'd say 2. Let's plug it in. What do you get? Well, the first factor, 2 times 2 is 4 minus 3 is plus. The second factor is 2 plus 4 is plus. That's 6, right? And the third factor is 2 minus 4, which is a negative number. Well, if you multiply a positive times a positive negative, what do you get? You would get a negative number. So this interval here is going to be negative. Let's go over here. Let's try a number between minus 4 and 3s. I say a really good number in between those two, but again, you're free to choose. I would choose 0. What would you get? Negative on the first factor, positive, and then a negative number on the third factor. Well, what does it give you? A negative times a positive times a negative. Overall, it's positive. All right, let's take a number below minus 4. What's a good test point over there? I'd say x is minus 5. If you plug that in, minus 5 in the first factor would be a negative number. It actually would be minus 13, right? Second one would be minus 1, which is a negative factor. And the third one would also be a negative factor. What does this give you? A negative overall. Now, what was their question? You have to know their question. If you don't know the question, you couldn't answer it. Their question is, when is it greater than 0? When it's positive. So where is it positive? I'm going to shade it in for you now. Positive here and positive here. And that goes on forever. All right. What's the other question? When is it equal to 0? Well, if you plug in -4, that expression becomes 0. If you plugged in 4, that expression becomes 0. And if you plugged in 3/2, that expression becomes 0. Let's write our solution down. Well, it starts at -4. Whoops. It starts at -4. It's on the left side, and it's inclusive. And that's our convention for that. It goes up to 3/2. That's on the right side, and it's inclusive. It touches it. Union starts up at 4. That's on the left side, inclusive. And then it goes off to infinity. You could never touch an infinity. Look at the key. Make sure you can agree with that. Let me repeat this. For some students, this may be going too fast for them. Not everyone's at the same speed. What you need to do, though, is if it's going too fast for you, you need to watch these videos off schedule. And there's many ways to do that. You can watch the lecture again, or what you can do is watch these little spot videos on the side. All right, you can watch those if you like. All right, let me go to the next one. And we're going to problem number 4 now. So let's take a look at number 4. And I'm going to, basically see if I can do it. Now, I realize, listen, I don't want to do what you're doing. I want to do it. We're not going to stop you. What we're going to stop you from is getting wrong answers. Unless we put wrong answers down and they look at my answer and say, oh, that doesn't matter. It does matter. That answer in the end is correct. And if it's not correct, I'd be ashamed of it. I really would be. What do? I want to emphasize we don't have a 0. And there's a problem right now. So what I need to do is I need to expand the left side. I'm going to write that down for you. That would be x squared. And you should have basic algebra skills. Minus 6x plus 9 is less than or equal to 1. And then what would I do? I would subtract 1 from both sides with the intent of getting it compared to 0. That part's done. Now what do? I'm going to make some attempt at factoring it. And I'm hoping they're really easy to do. We're not trying to give you problems you really can't do. I can say 2 and 4. Now let's see, what would you get there? I'd say minus minus. Does that work? You get x squared. -4 minus 2 is -6. And -2 times -4 is +8. What do I do now? Number line. What goes in a number line? The zeros of those factors, which would be 2 and 4. I'm getting a little better. I'm not saying you are. You haven't tried yet. You'll get better by trying. What do you put over here? Test point. I'd say a good test point over here would be 5. What's a good test point between 2 and 4? I would say 3. What's a good test point over here? I would say 0. Plug it in. Plug in a 5. What do you get? Positive times a positive. Well, I hope you realize a positive times a positive is a positive. So this entire interval here is positive. That goes on for a long time. If you plug in 3, well, 3 minus 2 is positive, and 3 minus 4 is a negative number. What's a positive times a negative? A negative number. So this interval here is all going to be negative numbers. Let's try the 0. What do you get? A negative times a negative, which is a positive number. This entire interval is positive. Here comes the trouble. What's the question? The question is, when is this less than 0? Only when it's negative. I'm going to shade that in for you. It's negative right over here. What's the other question? Is it equal to 0? Well, if you plug in 2, it becomes 0. And if you plug in 4, it becomes 0. What's my interval over here? Well, it starts at 2. That's on the left, inclusive. And it goes up to 4, which is on the right, also inclusive. I see that answer right there. Again, work is important. Let's go to number 5. And I'm looking at again, what's the problem with number 5 is no zeros there. I got to get that. Okay, let me communicate again because I know it's difficult. If you're looking at this thing and you're saying, I don't know what to do, you might have to slow yourself down and study the material more. But the bottom line is we've got to get 0. How would you do that? Subtract 16 from both sides. And that's a very easy thing to do. And what would you get? X squared minus 6x. Well, 9 minus 16 is minus 7. All right, so that's done. So I got to compare it to 0. First step. What's next step? Factor it. X. And what do you get there? 7 and 1. So I'd say minus 7 plus, let's see if that works. You get x squared minus 7x plus 1x minus 6x. That worked. And you get minus 7. What goes in the number line? The zeros of those factors. Well, x plus 1 becomes 0 at minus 1, and x minus 7 becomes 0 at 7. What are you going to do now? Test points, right? And you might get really fast when you start to try this. What's a good test point after 7? 8. Plug it in, what would you get? A positive times a positive, which is a positive. This entire interval is positive. Let's take a test point between minus 1 and 7. I'd probably say 0. But you can choose any number between minus 1 and 7, and you're going to get the same result. So if you plug in 0, what do you get? Well, 0 plus 1 is a positive number. However, 0 minus 7 is a negative number. What's a positive times a negative? A negative number. This entire interval is going to be negative. No matter what number you choose in an interval, the product would produce to be a negative number. Now, what do you do over here? A number below minus 1. I would say minus 2 is a good choice. And what do you get over there? Well, minus 2 minus 1 is a negative number. I'm sorry, minus 2 plus 1 is a negative number. And minus 2 minus 7 is also a negative number. What's a negative times a negative? A positive number. So this entire interval is positive. Here comes the trouble for students. They have to be able to read that. What does it say? This thing here, which we just analyzed, must be greater than 0. What kind of numbers are greater than 0? Only positive numbers. So I'm going to shade in the regions that are positive and then write my interval down. What's my interval going to be? Well, moving left to right, minus infinity. You can never touch that, but it's on the left. Up to minus 1. Minus 1's on the right, and you're not touching it. Union 7, which is on the left, and you're not touching it, and it goes off to infinity. All right, we're looking at those answers right over there. Let's go to the next one. And again, a lot of people look at these things and say, I don't know how to answer that. Well, it's really the same story over and over and over again. What do? Compare it to 0, completely factored. And this guy, the problem is written perfect. Right? What do I mean by that? It is compared with 0, and it's already factored. All right, so what am I going to do? I'm going to write it down now. And what are the zeros? Right? The zeros are going to be at 0. That's when x4 becomes 0. And the other 0 is going to be at the number 2. All right, so 0 makes it 0, and 2 makes that 0. What am I talking about here? This thing right over here. So all we're talking about. So what am I going to do now? Test points. What's a good test point after 2? I would say 3. If you plug in 3, what do you get? Well, 3 to the 4th power is a positive number. And 3 minus 2 is a positive number. I hope you can agree a positive times a positive is a positive. So this thing over here is a positive number. That's done. Let's go below 0. I'm sorry, not below. Let's go between 0 and 2. What's a good test number there? Probably 1. What's 1 to the 4th power? Positive. What's 1 minus 2? Negative. What's a positive times a negative? Negative number. That's done. Let's go to the next interval, below 0. What's a good choice below 0? Minus 1. If you plug in minus 1 to the 4th power, that would turn to be plus number. Let me repeat that. Minus 1 to the 4th power is 1, which we know is a positive number. Now, what's minus 1 minus 2? It's a negative number. What's a positive and negative? A negative number. This entire interval is negative. All right? Now let's see what the question is. And I'm looking at it, and I hope you're looking at it too. What does it say? When is it greater than 0? Well, the only time it's greater than 0 is when it's positive. So I got this covered over here. What's the other question? When is it equal to 0? Well, I'm hoping you realize if you plugged in 0, it would be equal to 0. And if you plugged in 2, you get equal to 0. Well, I'm going to write it down now. And certainly sometimes it look really odd when you write this down, and it does look odd. I'd hate to think you write this down this way, but you could. Okay, moving left to right, it starts at 0 on the left, close bracket, because it touched it. And it stops at 0 on the right. Union starts at 2, that's on the left, close bracket, and it goes off to infinity. This is a fine answer. It's right over here. It looks odd to me. I'll tell you why it looks odd. The interval from 0 to 0 is only one element. We typically can list that. We list it by using set notation. There's only one element in an interval, which is 0, union 2 to infinity. Now, someone says, could you use set notation on 2 to infinity? Absolutely not. You couldn't list all the numbers. That's also listed for you. All right, so let me, briefly tell you what we've done. We've done some examples for you. All right, so we've done enough examples that certainly saying you have an idea what to do. There'll be a chance for you to try on your own, though. All right, thank you.